Okay, I want to do a little video about list comprehensions in Python. I know I found them very confusing when I was just starting with Python, and a lot of people I know struggle with the concept, and it's really a syntax thing. So let me show you a list comprehension in Python. Classic one, multiply a number times 2, x times 2, for x in range 1 to 10, and run that. And we get all the numbers from 1 to 10 multiplied by 2, although because this is Python, we don't get the last one, we only get up to 9. It leaves off the last element. So if we wanted to get all the way to 10, we'd have to do that. And then we get up to 10. So what is it doing exactly? Well, one way I explain this is with for loops. So we could say, find my code here. I could say for x in range 1 to 11, print x times, Python 3, x times 2. And if we run that, we should get similar but not quite the same output. The difference being that is a list comprehension, it produces a list, whereas this is just running through each of the items and printing each one and giving us a new line after each one. So an actual list comprehension would be more like setting up a list like, we'll call it A for no good reason, and we'll make A an empty list, so we initialize it, and then we could say a dot append x times 2. And then we could, at the end of that, print out a. And if we run that version, we get the same thing as we got in the first time. And to show that we really are creating a list, we could say a equals this list comprehension, and then we print a. Now, what I think people find confusing is also you often see something like x for x in, and let's put something here, we'll make it, I think we can do it with a string. And if we run that, I get each element from the string. And I think people read this as x for x, at least I used to. And you go x for x, well, how can x be for x? That's very confusing. And it's really about x is in this thing. It's a for loop. And again, it's this for loop syntax. But let me try to explain this by going to a rather unexpected place, which is the most terrifying of all languages. Well, actually, that's APL. Let's instead go to Haskell, the second most terrifying language. I'll make a main, and I'll do nothing. Print. And I'm using something called the Haskell language server, which automatically suggests types for my functions. Because Haskell, as a purely functional language, you give it type definitions for every function that you create. So what this says is main is going to say print hello world, and that main itself is a function whose type is an IO. It's going to perform IO. And then I can, so I got to save it first. And then I can compile it and run it. And I've got this nifty thing here in VS Code that lets me open it up and run the program. If anyone's interested in how I set up Haskell in VS Code and the Haskell language server, let me know in the comments. I'll be happy to do a little quick video on that. So here we are in Haskell, and I can say main, and it prints out hello world. But I said list comprehension, so let's do that. Let's say that A is equal to A, well, let's say X again, use the same thing. And this is the Haskell syntax for it. I'll make it a range. And in this case, what we're going to get, if I say what is A, I get the list of 1 to 10. Haskell leaves the last number on. Look at that nice rollover And it suggests to me that I haven't said anything, that my x for x in 1 to 10, I just refactor it as 1 dot dot 10, which is the same thing as Haskell, as Python's range function. It's very smart, much smarter than I am. But the way you read this is x where x is taken from, at least the way I read it. X is taken from this list, say 1 to 10. And for me, that's a lot simpler to understand. There's no 4 and 4 thing here going on. And there's a clear separation between the thing I'm producing and where it's coming from. So if I wanted to make it times 2, I could do that, save it, recompile it, and then I could say, what is A? And now I've got 2 times each of the elements. And I just find the way that Haskell expresses this with the vertical bar to separate out where things are coming from where they are going, very handy. I'm going to add one other thing, which is I could also take from multiple inputs. Well, I could say y is taken from, where's my sign? There we go, 1 dot dot 10. So now I'm going to have 2 inputs, and I could say x times y. Now what is A? I've got a whole bunch of stuff here, and I've got all the multiplications of everything from 1 to 10 multiplied with everything from 1 to 10. I essentially have a times table up to 100. And we could filter that. And we could filter that by using a filter function or some other way. But the nice thing about Haskell is I can put it right in here and say where x times y is less than 50, say. I'll put spaces in because spaces are cheap. I've reloaded it. I run it. And now I only get items that are less than 50, which is pretty nifty. How would you do that in Python? Well, first you could say x times y for x in range 1 to 11 for y in range 1 to 11. And if I run that, I get the times table up to 100. Of course, it's printing it all out on separate lines. I think if I do a print here, if I assign it to a variable, and then I print that variable, I don't think I'll get all the line breaks. There we go. Same thing. But that, to me, I look at something like that for this and this, for this and this, and I just get really confused. It is the same as nested for loops, and it's just a more concise syntax, but I think because Python's trying to get you to understand it's the same as a for loop, the syntax is a little confusing. And if I want to do the same thing as I did in Haskell where I limit to less than 50, I can put a condition, and in Python that's an if statement. If x times y is less than 50, and if I run that, I get the same thing as I did in Haskell. So again, I can add a condition in Haskell. Let me just remind you, syntax a little more terse, but that terseness, I think, makes it easier to see what's going on. Thanks very much. If you have any interest in anything more like this, glad to, but this might be just a one-off.